So in this video, I'm going to show you how to conduct a dependent samples t-test. And just briefly, so recall that a dependent samples t-test is when you're gathering data repeatedly, so you're getting two measurements from the same sample, the same group of entities. So that would be you're giving a test to the same group of students at two different times or something like that. So that's when you would use a dependent samples t-test. What we're going to do here is look at how we can run that in Stata. You'll see that I've got Stata already open. I've already got data loaded into Stata. So over here is a set of variables that I can use. Down here is the some information about the data. And so let's say that I want to look at, let's scroll down through here and look at all of the different kinds of variables that we might be able to use. And so let's say that I'm interested in math achievement amongst high school students. And let's say that, in high schools, students can take the ACT, the SAT, and the PSAT. And so let's say that I'm focusing on the ACT and the SAT. And so let's say I want to know if math achievement on the SAT and math achievement on the PSAT at each school are similar, meaning like do the students who take the PSAT, do the students who take the SAT at one school, is their math achievement similar to or different from the math achievement of the students who take the ACT at that school? And so one thing to start off is you might have already realized that the ACT and the SAT use different scales, with the SAT maxing out at about 1600 or at 1600 and the ACT maxing out at 36. So one thing that we'll want to do first is standardize these two variables so that we can compare them. So I'm going to use this command here. So I'm going to use the egen command, create a new variable called zMathSAT. I'm just going to say to standardize. Let's see, math ACT, math SAT right here. So I just clicked that and brought it down into the command line, hit enter. And so that created a new variable called zMathSAT. Now I want to do the same thing, but for math ACT. So I'm going to do basically the same thing, but just use the ACT math variable. Okay, so now I can see that if I scroll down here, these are my two new variables. And to conduct a dependent samples t-test, it's pretty straightforward. So you don't have to, so this is going to use the mean and distribution for each of these variables and stuff like that, but we don't actually have to work with those particular numbers. We just need to know what command to use Stata, and it will do all the calculation for us. And so we do that just using the ttest command. And for a dependent samples t-test, what we do is we would just say, we're telling Stata to conduct a t-test to see whether math SAT is the same as math ACT. And so this creates a table for us. And what we can see in this table is that the top couple of rows here, these are just descriptive statistics. So this top here is math SAT, down here is math ACT. And this shows the number of observations that are used. And here it's 307 because to be included, a school has to have a value for both of these variables. Otherwise, it's dropped because it's not going to be useful for our comparison. And this, kind of reading across here. So this is the mean. So this is the average z-score for SAT. This is the average. This is the average z-score for math ACT, the standard error, the standard deviation, and the 95% confidence intervals around all of these means. So then down here, this row that says diff, so this gives us information on the difference, the mean difference between these two variables. So again, we see 307 observations, because it means that what this means is that Stata has 300 observations, so 307 observations that are used to make this comparison. This here shows the mean difference. So up here where we see for math ACT, it's 3.4 E -9. So this is scientific notation. It means it's just a very, very small number, like very close to 0. It's 0.00000, a couple zeros, and then 3, 4. So down here, this is the mean difference. So on average, there's a difference of a little over 0.3 of a standard deviation in average math achievement within, in each school between the SAT and the ACT, with SAT achievement being a little bit higher. And this is the standard error of that difference, the standard deviation, and the confidence interval for this mean difference. And so what we can see descriptively is that in schools where students take both the SAT and the ACT, that their SAT scores are a little bit higher. Their standardized SAT scores are a little bit higher. To see whether that difference is statistically significant, we can do two things. One is you can look at the confidence interval and see if it includes 0. And if not, then this would tell you that it is statistically significant. Or you can come down here and look at the p-value, which is more conventional. So you'll want to look at this set down here, this set of information, these two lines right here in the middle. And so this is telling you that for the null hypothesis, that the mean difference is 0. The p-value for that null hypothesis is 0.00000, so much less than the threshold of 0.05, so you could reject the null hypothesis and conclude that this difference in means is statistically significant. Over here, these are for directional hypotheses, which are not all that rarely used, so I'm not going to get into them, but just suffice to say that when you want to interpret the p-value from a dependent samples t-test, you want to use this set of lines right here. And so that is how you conduct a dependent samples t-test using Stata.